Okay, we are going to continue talking about trig functions of famous angles. We talked about 45 degrees in the previous lecture. We are going to continue talking about two other famous angles, 30 degrees and 60 degrees. I'm going to talk about 0 and 90 degrees later on. After that, we are going to talk about arbitrary angles. Like, for example, what about sine of 22 degrees? How do we figure that out? Well, right now our solution is to either use a calculator or use a table. If you want to do it actually yourself by hand, then you have to take calculus 1 and then calculus 2. In calculus 2, we tell you one way of figuring out sine of an arbitrary angle by yourself. So if you were stranded on an island and your main worry was what is sine of 22 degrees, you will have a way of doing that. So you don't have your calculator and such. So yeah, there are ways of doing it, but it's a little bit more sophisticated than what we are using for finding these famous angles. So that has to be postponed, and we are going to also emphasize that you need to have your calculator early on, learn how to use various buttons on it, resolve all of your issues, so that when you want to use these functions in applications, you will have no problem using your calculator. Okay, so we are going to talk about arbitrary angles. For arbitrary angles, we are going to have more defined ways of measuring angles. So other than degrees, we have minutes and seconds, smaller units of angles than degrees that you can use to measure an angle. And again, there would be other ways of measuring. We are going to talk about that later on. Next, we are going to talk about so-called cofunctions. You can tell from the way we talk about these functions, their names, that for example, you have the function sine, and then you have another function cosine. So the word co is added to this. And this pair of functions are referred to as cofunctions. We have three pairs of cofunctions that we talk about, and we are going to talk about cofunction identities. So that's the plan for the lecture for this hour. Let's see how much of it we can cover. First, let's go after these two famous angles, 30 degrees and 60 degrees. The 60 degrees angle should remind you of something in geometry. In geometry, if you have an equilateral triangle, a triangle, all of its sides are the same. So if this is A, this is A, and this is A. So it's an isosceles triangle three ways. That is, these two are the same, and if you wish, these two are the same, and again, these two are the same. So all the legs are all equal to each other. We call it equilateral. If a triangle is equilateral, what happens about its angles? The three angles are all of them equal to each other. And since their sum is 180, each of them has to be 60 degrees. So the 60 degrees shows up here. So we remember in the back of our mind that one way to get to 60 degrees is to start with this. And of course, if you split it into halves, then these are going to be 30 degrees each. So this is 30 and this is 60. So that's going to be our basis of our work that we are going to do for finding out the trig functions of these two. The way we go about it is the following. We say, okay, suppose this length is A. since we split this into half, this one is going to be how long? Half of a, so we call it a over 2. We say, okay, how about this other leg, which is kind of altitude of this triangle? How about that? We don't know what that is, so for the moment we call it x. Let's go ahead and see if we can find x, given that we know what these two are. So what is the relationship that comes to our help in figuring this out? We have a right triangle, and we are talking about the three sides of it. So we are going to appeal to which theorem? The Pythagorean theorem, is that right? That's essentially the only thing that we have available. This entire course is built on that single theorem. So a squared has to be square of this, x squared, and square of the other one. So this is the Pythagorean theorem. What happens next is that we are going to rearrange this until we find x in terms of a. Because we assume we know what a is, we are trying to find what x is going to be. We did this thing last time. Let's try it all over again. So I start a squared, I copy this, x squared, a over 2 squared. When I square that, what do I get? A squared over 4. Now what do I do next to isolate x squared? Subtract a squared over 4 from both sides. So I say a squared, I subtract a squared over 4. Last time I emphasized that you need to do this thing in a single step. Sorry. So in high school you say I go ahead and subtract, you write something like this, and then you add these two to get that. I want to ask you to go into a single step and jump from here to the next one. Next issue, I want to subtract these two, but they have different denominators. This denominator of this thing, which is not there, is really 1. I want to see a 4 to be able to do the subtraction. What is the trick that's going to help me there? I have to take a common denominator or multiply these two by a 4. So on the left hand side I have a common denominator of 4. Now I can subtract the numerators. 4a squared minus a squared, that is equal to x squared. So I can write this x squared. What is 4a squared minus a squared? So x, we are going to take square root of this and stick to the positive side. So 3a squared over 4. As we said before, you can split it into two pieces. A squared over 4 is nice to handle. Radical 3 just gets stuck inside. What is the square root of a squared over 4? A over 2. And this is square root of 3. So all this work we did was to find out that x is a over 2 radical 3. Now let me redraw this triangle so that we remove all this clutter here. Let's remember, if the hypotenuse is a, the opposite is half of that, that is, opposite of 30 degrees is half of the hypotenuse, and adjacent to 30 degrees is a over 2 radical 3. So let's redraw this thing. So again, this was 30, this was 60, this was a. Opposite of 30 was half of this. And the other one was what? A over 2 radical 3. Now again, we are going to practice the three definitions of, definition of the trig functions. Let's start. How about sine of a? Sine of 30 degrees. Sine was a ratio of which two sides? Opposite and the hypotenuse. So a over 2 divided by a. Do you know how to divide two fractions? Well, in this case, the answer is simple. What is the answer? The a is cancelled, and you have 1 over 2. How about cosine of 30 degrees? Ratio of adjacent by hypotenuse, and when we simplify this, what are we left with? Square root of 3 over 2. A is cancelled, we have square root of 3 over 2. What else? Tangent of 30 degrees. Ratio of opposite to adjacent. So I have a over 2 and then a over 2 radical 3. A over 2's cancel out, and I'm left with 1 over radical 3. That rationalization trick that we applied, we can apply here as well. 1 over radical 3, what can I do to it? Multiply by the denominator. What is the benefit? The benefit is that these radical 3's combined to give us a 3. So that's just another form of the same answer. Okay. All these A's here might kind of throw you off a little bit and make life a little bit hard for you. Here is a shortcut or a trick that can kind of help you with these fractions. The idea is choose a value for A that make life easy for you. Since it doesn't matter what A is, it always cancels out, you just go ahead, pick a value for A that makes life easy. One reasonable value is just 2. If this is 2, the opposite of 30 degrees is going to be what? Which is 1. And how about this one? 2 over 2, that cancels out. So one of the pictures that should be in your notebook on a meaningful page is, in order to remember what to do with 30 and 60, just draw a triangle, right triangle. Hypotenuse 2. Opposite of 30 is going to be 1, and the third side is going to be radical 3. Several things to help you here. This small angle, the side opposite of it is also the smallest number. Also, if this is 2, this is 1, Pythagorean theorem quickly tells you this has to be radical 3. Okay, with all this information, let's go ahead do the other 3 functions. For example, cosecant of 30. That's a ratio of hypotenuse to opposite. So it's just 2 over 1, which is just 2. You could have done it here as well. You would have said a over 2, and then you just get 2 out of it. Next, secant of 30. Secant is a ratio of hypotenuse to adjacent. So that's going to be what you said? 2 over square root of 3. Notice this is the same fraction, just turned upside down. What did we call that? Reciprocal identities. These two functions are reciprocal functions. The values are reciprocal. Finally, cotangent of 30 degrees. Ratio adjacent to the opposite. What is that? Square root of 3. So for 30-60, this picture is very handy. For 45, if you want to have a quick memory aid, perhaps this triangle is going to be easiest for you to use. 45, if you take the adjacent and opposite to be 1, hypotenuse becomes the square root of 2, and you can use this triangle to quickly write all the 6 trig functions of 45 degrees. Okay, we took care of 30 and 60. Now we have to go to mature and go after angles that are not so nice. So that's the issue of arbitrary angles. So let me go back and say, okay, we have done these. Next, we want to talk about arbitrary angles. What do we do? So suppose you want to deal with sine of 22 degrees, or sine of 67 degrees, or cotangent of 35 degrees. It's not one of these famous angles. What do? Our basic approach here is to use a calculator. In old days, there would be a table at the end of the book that would help you with this kind of calculations. Those things have kind of gone out of fashion in the last 20 years because the calculators became so cheap. It's easier to use a calculator than to flip through the book and try to find these things over there. So on your calculator, you need to figure out where the buttons are and what they do. Since there are so many makes and models, we cannot give a standard answer. If you have any question about your calculator, you are going to come to me and we are going to take a look at it. Try to find the website of the calculator or keep the manual that comes with it. It shows you enough examples so that you can answer your own questions. So in general, a basic calculator has just 3 buttons for the 3 primary functions. There is a sine, there is a cosine, there is a tangent. That is common. After that, every calculator does it differently. Very, very basic calculator with a single line display, they will expect you to enter the quantity first, then decide what you want to do with it. Okay, like the calculators that are below $10, they do like this. You do 22, and then you press the sign button. Newer style calculators in the last 10 years or so, they help you by using the so-called display style. That is, they expect you to type it in the way you see it. These type of calculators, you press sign, typically a parenthesis shows up, or it might not show up. So as soon as you press this one by itself shows up. You enter your angle, and most of them accept if you press the enter button, but as a matter of good practice, an open parenthesis is better to be closed. So you close it. There's a parenthesis button on a calculator that probably you haven't used it in your life, but make sure that you note where it is, and then at the end of that you have to remember to press depending on your calculator, either equal sign or enter button or one of the variety of things that forces the calculator to actually do the calculation. Okay, so your calculator, if you want to use it for an arbitrary angle, for sine, cosine, tangent, first of all you decide which one of these 2 formats it is, and then you go ahead and practice a few cases. Make sure you get the correct answer. So very basic thing to do on your calculator is to get sine of 30 degrees. Everybody who has a calculator now, I want to ask you to actually do that and make sure that you do get, what answer do you expect to get? 0.5. Okay, again, depending on what type of calculator you bought, it might show 0.5, it might show 1/2. We'll talk about that later on. But either of the 2 answers will be acceptable. Make sure you get this one right. Next is the issue of what if I wanted to have cosecant of, say, 72 degrees. What do? We go back to the reciprocal identities. We say cosecant of 72, 1 over what? Sine of 72. That is, cosecant is a ratio which is the opposite of a ratio of 72. So you figure out 72 and then you take the reciprocal of that. Now again, it depends on your calculator style as well as how confident you feel about using a calculator. There are many ways of calculating this. So what you do is that this is a very basic one. You calculate sine of 72, you find out what that is, and then you want to take the reciprocal of that. One of two ways. There is actually a reciprocal button on many calculators, 1 over x. Or if you don't locate this thing, or it is just not there, you have to say 1 divided by, let's assume that we have one of these calculators, 1 divided by, you press the sign, it opens parentheses for you already, most of them do. You say 72, close the parentheses, and then press the equal sign. Most pressing issue that comes up there is that when you type things in the calculator, you have to know that the calculator follows a certain order of precedence, and that is the order of operations you have learned in college algebra. Do you remember what comes up first? So when you are using the calculator, you have to be aware that when you are doing several things on a calculator, or if you tell somebody to do several tasks, he's going to ask you, what do you want me to do first? In mathematics, there is such a thing as an order of operation. There's a standard priority list. What is on the top of that heap? Well, parentheses is on the top. What is next? Exponents. Next, multiplication and division. Next, addition and subtraction. And then within these things, we need still tiebreakers. Several parentheses, you work from innermost to outermost. Exponents, you work from top to bottom. Multiplication and division. What is tiebreaker if you have several multiplication divisions? So for example, you have 2 divided by 10 divided by 100. Yeah, this is resolved from left to right. Addition, subtraction, again, is resolved from left to right. At any rate, you have to be aware of such an issue so that when you use your calculator, you don't enter things incorrectly. Again, I want everybody to try cosecant of 30 degrees. What answer do you expect to get? Cosecant 2. So follow this operation. See if you get 2. If not, come and see me after the hour, and let's see what step is it that is not being done correctly. So short end of this story, the 3 primary functions are on a calculator. The other 3 you have to use with the reciprocal identities. Whatever you are doing with the calculator, you have to be aware that you have the issue of order of operation. You want to take care of that. So we have now talked about this one. Next issue is the issue of units, small units of measurement. So a degree is a small angle already by itself. How do you define a degree? You take a right angle, divide it to 90 pieces. I'm already exaggerating. This is going to become a very small angle. Or you can start with a whole circle, divide it to 360 pieces. So 1 degree is 1 over 360th of a circle. That is, if you had a pizza and you had invited 360 people, you have to cut this thing at 1 degree intervals to give everybody a piece. It's a very small angle, but from ancient times people could measure small angles, so a degree wasn't a big angle for them. Why 360? perhaps a little bit of a mystery. Maybe it's related to the fact that there are almost 360 days in a year. So if we were living on some other planet, perhaps this number would have been different. Second reason for that is that some ancient civilization just loved this number. 360 is connected to number 60, has lots of divisors. So there's a little bit of history with that number. So it looks rather arbitrary. Why 360? We are going to talk about that. But our issue is that for many measurements that they used to do, this wasn't precise enough. So they would take 1 degree. This is again coming from ancient days. They break it up to 60 pieces, and that makes 60 minutes. So 1 minute is 1/60th of a degree. As if that wasn't enough, they will go one more level. Let's say 1 minute is equal to 60 seconds. So by now, 1 degree is going to be how many seconds? 1 degree is 60 minutes. Each minute is 60 seconds. So 1 degree is how many seconds? Careful. 1 degree is 60 minutes. Each minute itself is 60 seconds. So my question is, fill up that blank. You take a degree, break it up to 60 pieces. Each of them becomes 1 minute. Take each of them and break it up 60 more times. That becomes seconds. So by now, how many seconds are going to fit into a degree? Very good. 3,600, which is 60 times 60. Each of these gives birth to 60 of these. So 60 of them is going to give birth to 3,600. So this angle, as small as it is, if you divide it by 3,600, you see a second. One of the places that you might see this is on the deed for your home. If you go get the deed for the home, you will see this terminology there. People don't stop there. Actually, even a second could be a big angle. Even though we don't use it in the text, it doesn't show up, or it doesn't show up on your calculator. People keep doing this. So 1 second is 60/3, and so on. But we are going to use decimal in general. Yes. That's, many of astronomical discoveries and such are based on the fact that people could measure these things so precisely and notice that the numbers don't match with whatever they were expecting. So that kind of discrepancy led them to think that there has to be some other planet that is pulling or pushing these things, pulling them actually, and that led to some very important discoveries for the outer planets. Lots of sweet stories related to that actually. Okay, what about the notation? We're running out of time here. So what does this mean? Yes, this means 2 degrees plus 5 minutes plus 13 seconds. Suppose I want to convert this thing and see it totally in terms of degrees. So we are going to talk about conversion issue. So all those conversion things that you have done in high school, it's very similar to that. So 2 degrees is just 2 degrees. 5 minutes. How many minutes made a degree? 60 minutes made a degree. So 5 minutes is going to make what fraction of a degree? 60. So to convert this thing into a degree, we have to divide by 60. 13 seconds. You remember 3,600 seconds makes a degree. So 13 seconds is going to make 13 of 1 over 3,600 of a degree. This whole thing is now in degrees. So if I have degree, minutes, seconds, I want to convert it to degrees. I take my minute number divided by 60. I take my second number divided by 3,600, and the whole thing is going to be how many degrees we got. The story is also practiced in reverse. Suppose I have 2.3 degrees. So this is a decimal degree. I want to convert it to whole degree plus some whole minutes and some whole seconds perhaps. So I say, first of all, well, this obviously has 2 degrees in it. 0.3 of a degree is going to give me how many minutes? So I have 0.3 of a degree left. Each degree is 60 minutes. So what do I do? Times 60, and that's going to give me what? 18, I guess. Is that right? So 2.3 degrees is 2 whole degrees and 18, what did I say? Did I say minutes? No. 18 minutes. And so on. So you do some conversion between the two formats, and then for the last item for today, we are going to talk about cofunctions. Let me explain it in the context of an example first, and then we are going to write it in general. Suppose I have a right triangle. Say I tell you this is 22 degrees. How big is that one? So the sum of these two is 90. If you are telling me one of them is 22, the other one is going to be what? 68. First of all, we call these two complementary angles. Okay? These are going to be complementary let me redraw this thing that got crowded. So this is 22, this is 68. For the moment, let's go call these sides A, B, C, whatever they are. Suppose I ask you what is sine of 22. So, well, ratio of opposite to the hypotenuse, whatever it is. Suppose I ask you what is cosine of 68. It has to be ratio of adjacent of 68 to hypotenuse, which is what? U over C. So you notice that these are the same thing. Sine of 22 is same as cosine of 68. We say these are complementary, and this pair of functions are called cofunctions. Then we say cofunctions of complementary angles are equal. Let's write it first. Cofunctions of complementary angles are equal. What do you mean by this? Here's complementary angles. I write pair of complementary angles. Then I pick a pair of cofunctions. What do you mean cofunctions? Such as sine and cosine. They are the same. Or I could have chosen cosine here. And who is going to be the function on the other side? Sine. I ask you to fill in the detail here. Tangent of 22. You tell me what should show up on the right hand side. Who do you think is a cofunction of a tangent? I'm just take a wild guess. Cotangent. And the complementary angle of 22 is what? 68. If I had started with cotangent of 22, what do you think should show up on the right-hand side? Tangent of 68. You cook up the other one for me. There is a third pair. What are the two cofunctions there? Yeah. So suppose I had secant of 22. What do you think is on the other side? Cosecant of 68. Or if you had cosecant of 68, that would have turned out to be secant of 22. So the way you do it, I explained for the first one here. The rest of them, you try the same thing that I did on this picture. Write one function of one of the angles and then a cofunction of the complementary, and you'll see that they all turn out to be the same thing. So here is an abbreviation for the whole thing. Let me write it in general, and then we are going to be done. So if I have some arbitrary function, its complementary is 90 minus theta. If I take sine of this, same as taking cosine of that. If I take cosine of this, same as taking sine of that. If I take tangent of this, you tell me what to write on the right-hand side. Cotangent of, if I had started with cotangent, I would have had tangent on that side. If I had secant, cosecant of the complementary you get it by 90 minus the original, and if you had started with the cosecant, you do it secant of 90 minus theta. So these are called cofunction identities. So today we learned two types of identities. What were they? Reciprocal identities and cofunction identities. They are inside the umbrella of symmetric identities. We'll talk about them later on. So for tomorrow, you want to make sure you get registered on the MML and do the exercises of 1-1. If you don't have MML, just do all the odd number problems. Write it down and be prepared to come to the board and do a random problem from the set. Okay. Good luck and see you tomorrow.